Hello and welcome back to the Coking.com channel. I am on the shop floor with our friends at MIAM. And as you can tell, we have this beautiful black beauty behind us. But before we get to that, I'd like to introduce Kanan Fontenot with MIAM. You want to give a little quick introduction?
My name is Kanan Fontenot. I'm the North American manufacturer for the MIAM GmbH company, and we manufacture specialty products for severe service applications.
Cool. Well, thanks, Kanan. And this very large valve we have behind us is a 16-inch InnoCON valve from the MIAM company. And so, Kanan, could you kind of give us a quick rundown on the parts of this valve?
Certainly. This is our InnoCON valve. It is a lift and turn plug valve, all metal seated, built for severe service, high temperature, the worst of the worst. Typically in a coker, it's used in inlet feeds as well as bypass, and also for overhead vapor lines. The way the valve works is pretty unique. It's a tapered metal plug in a all metal body. So we don't have any spring-loaded seats or anything of that nature. It's very, very simple. What you see is what you get. This valve is in the fully seated open position. Now, when this valve actually begins to cycle, as opposed to a lot of other types of valves that would turn quarter, the first movement of this valve is actually directly up. The plug, because it's tapered, and you'll be able to see here in a moment. So the taper on the plug allows for that first movement up. It loses contact between the seating surface on the plug and the seat that's integral to the body. While we're doing that, what we're doing is we're saving those sealing surfaces. They see less wear and tear. You don't have to load or do anything of that nature. What we're doing is when we actually cycle this valve and the seat or the plug goes down into the seat, you're actually wedging it or compressing it down into the body. So all we actually are doing to create a seal on the interior is actually loading from exterior of the process with our gearing system, which I'll go into in a moment.
So while the plug is in its fully unseated position, the steam purge would be going in through these body purges and kind of washing away any contaminants and keeping that.
That's a critical point, Evan. What happens is when the plug elevates, you actually do have a void where the plug's not contacting the body because we're trying to prevent that wear and tear, but you do allow, there would be the possibility of some fouling or coke particles in getting into these void areas. Because of that, we actually have on our body multiple purge lines. The purge lines allow us to actually inject steam or an inert material at a higher pressure than whatever the process flow is at. So as the plug elevates, that higher pressure purge media is going to spill out through these small orifices and keep the void area around the plug clean and free from debris.
Okay.
Now, the important thing on our design, you don't want to dump your purge media to process all the time.
Mm-hmm.
It creates a lot of cost, not to mention efficiency in your drums. So what we do, or the design does actually, is once the valve goes fully seated open or fully seated closed, the purge media is automatically shut off because the plug drops into the seat.
So there's no purge flowing when it's in its fully open, fully closed, only when it's traveling.
That's exactly right.
Interesting.
So it makes for an efficient way to prevent fouling of that cavity.
Okay.
So
good. Well, so as this valve continues to turn, Evan's going to come over here and continue to move. I want to bring special attention to this external indication. So we have this fully seated and fully lifted position, and this is the secondary visual indication for the valve, for the operators to understand, what's actually happening with the plug itself. And as it's turning and moving into its seated position, you see that's traveling down, all the way till it's fully seated. And if we pan back out, we can see that, that motion, Evan, if you want to keep on going back, opening with it, he's able to achieve this, relatively easily. And that's because there's not a lot of metal-to-metal contact. After it becomes unseated, it's free-floating.
Yep. Once that tapered plug, and it's important to note that we can actually do it in a full port as well. So 70, 90, or 100% port. When the plug fully elevates, it loses contact. So it's essentially free-floating. So any kind of torque requirement you have here really drops off the page. It's very, very low torque requirement. You only have really any kind of force or load requirement on your actuator or even your rim pull on your gear as you actually descend into the seat or come out of the seat. And actually,
probably some breakaway torque. I mean, that's been in the open or closed position for hours.
Yeah.
The torque curve, I imagine, kind of spikes up a little bit and then drops down into and then
it does.
When the valve is either fully open or fully closed, is the actuator setting is it set on torque or is it set on position?
Our valve, when we put an actuator on our system, we generally like to have it set as a torque setting.
Okay.
It's a torque seated valve essentially because we want to shove that plug into the body and create that seal.
"12-inch Class 600 InnoCON with InnoMod."
All that load, not necessarily torque, but force load is created with our InnoMat gearing system.
And I'd encourage you guys at home to check to our other video where we discuss the guts of this thing and actually how it works. That was discussed separately, but sorry.
Yeah, but this is designed to mimic the requirement of force and torque that the valve actually requires throughout the cycle. So actually, when we put an electric actuator on here, you want to set it on torque as your primary, and you want to set your start and finish torque at exactly the same number.
Okay.
The additional force difference that you need in the body is actually accommodated with the InnoMat device itself.
Okay.
So it actually has greater force capacity as lifting the plug out as it does going in. And in fact, our InnoMat, this is an IM 30. Our numbering system basically indicates tonnage of force. So an IM 30 puts 30 tons of force in the downward position and actually will double that to get it out. So 60 tons of force is what this thing can supply you to make sure that your plug comes out of the body.
Those Germans, they don't fool around.
They don't mess around.
They don't mess around.
And of course, once the plug is elevated, as you mentioned, it's essentially free floating, so we can actually rotate relatively easily. And you don't wear out your actuators, you don't wear out your operators, and it works reliably.
Interesting. Well, are there any other pieces and parts of this valve that we haven't discussed already?
I would just kind of give you an indication of how this thing actually works. We actually have a split coupler right here that connects the gearing system to the valve body. We designed this thing in such a way that it can be maintained kind of on the fly or easily done during an outage or a maintenance opportunity. This split coupler right here can be disconnected. It comes apart. You can break these bolts at the flange here, and this entire gearing system can be removed and replaced relatively easily and very quickly and get your...
How much time, roughly?
If everything is staged on your deck, probably 30 minutes.
Oh, wow. It's
very, very quick. It's very easy. It's very intuitive. No special tooling is required. All you have to do is know how to pull these bolts right here and these bolts right here.
Okay.
So what we're trying to anticipate is the unanticipated.
Yeah.
Should this break, something hit it or wear out or anything of that nature, it can be easily replaced and keep you running on the fly.
Well, if there's anything I know is that Coker people are excellent at breaking things. So challenge accepted.
Okay. Well, we'll see what we can do.
All right. Well, thank you, Kanan, and thank you for MIAM for sharing
Appreciate your time, Evan.
the InnoCON valve. Very impressive valve. They shipped it all the way to Germany just for today's video, so we want to say thanks to the folks in Germany for bringing this bad boy to Houston for us for today.
Yeah.
So check back to the coking.com channel for all things delayed coking, and we appreciate you watching. Talk to you soon.